Let's look at parabolas. We have different equations for parabolas here for different situations. So the first one, y is equal to ax squared plus bx plus c. That's your standard form of the parabola. You then have y is equal to a into x minus m into x minus n. Now this equation is used for when you want to find the equation of the parabola and you have the x-intercept. If you have the x-intercept, you use this equation. The next one is y is equal to a into x minus p all squared plus q. This equation you use when you have the turning point and you want to find the equation of the parabola. So let's look at our first one. F of x is equal to x squared plus 5x plus 6. They want us to find the x-intercepts here. For x-intercept, you make y 0. So 0 is equal to x squared plus 5x plus 6. You need to factorize now using the cross method. So your factors will become x plus 2 and x plus 3. You now take each bracket and make it equal to 0 and you solve for x. So x is equal to negative 2 or x is equal to negative 3. If you have having trouble factorizing using the cross method or factorizing a trinomial, refer to the video we did in the algebra section for it. Okay, the next question, find the y-intercept. Y-intercept, we know that the rule is to make x 0. So wherever I see x in the equation, it becomes 0. Y is equal to 0 squared plus 5 into 0 plus 6. So y is equal to 6 is my y-intercept. Let's find the turning point now. The turning point, we start with the equation x is equal to negative b over 2a. So my b value is positive 5 and my a value is 1 here in the equation in front of x squared. So negative 5 over 2 times 1 gives me negative 2 comma 5. I need to take that negative 2 comma 5, sub into my original equation. So wherever I see x, I'll sub negative 2 comma 5. And that's going to give me a y value of negative 0 comma 25. So my turning point then is negative 2 comma 5 and negative 0 comma 25. The next one, find the axis of symmetry. The axis of symmetry, remember, is the x value of the turning point, and that was negative 2 comma 5. So my axis of symmetry is an equation which is x is equal to negative 2 comma 5. Sketch f of x. So if we are to sketch the graph, we need to plot our x-intercepts, which is negative 3 there and negative 2 here. We need to plot our y-intercept, which is positive 6, which is not shown on this graph, but the graph should cross the y-axis at positive 6, and that does need to be shown. And the turning point as well. The turning point is negative 2 comma 5 for x and negative 0 comma 25 for y, which is here. So we need to join all those points and you'll get your graph. Remember that the graph, you must show the graph going through the y-intercept of positive 6 as well. State the domain of f of x. In a parabola, the domain is always x is an element of all real numbers. The next one, state the range of f of x. Now the range is, you need to look at the y value of the turning point. The y value of the turning point here is negative 0 comma 25. And you need to determine whether the graph is covering all the y values above that number or below that number. I can see that negative 0 comma 25 is here on the y-axis, and my graph is covering all the values for y that are above. So y is greater than or equal to negative 0 comma 25 is my answer for the range. Given f of x is equal to ax squared plus bx plus c, and g of x is equal to mx plus c. So we have a parabola and a straight line graph of which both equations are unknown. So our parabola is our red graph f of x and our straight line graph is our g graph. There we go. Determine the equation of f of x. So we need to look at what information we are given for f of x, and we are given the x-intercepts here, which are positive 2 and positive 5. So we will use the equation here, f of x is equal to a into x minus m into x minus n, where m and n are my x-intercepts. So if my x-intercept is positive 2, I need to sub in 2 there. and my x-intercept is 5, I need to sub in 5 there. So it becomes f of x is equal to a into x minus 2 into x minus 5. We need to now substitute a point on the graph. I can see we are given a point 6 and 4 there, so we'll sub 6 and 4 that lies on the graph of f of x, where 4 is y and 6 is x. Sub that into the equation and you work out your a value. That works out to be positive 1. You need to put that a value back into this line here, this equation. So f of x is equal to 1 into x minus 2 into x minus 5. Open that out using FOIL, put your like terms together, and you'll end up with f of x is equal to x squared minus 7x plus 10. Let's look at another one. F of x is equal to ax squared plus bx plus c, and g of x is equal to mx plus c. Sorry, the same graph again. The next question, determine the equation of g of x. So g of x is our straight line graph. We need to determine, we need 2 points on the graph of g of x. I can see we only have 1 point here, which is 6 and 4, one of the points of intersection. So to determine another point on g, the only one I can see will be here. The y-intercept of f of x is the same as the y-intercept of g of x in this case. So if I can work out the y-intercept of f of x, I'll use that for my g graph as well. So the y-intercept of f of x works out to be 10. You let x equal 0. So my coordinate I get is 0 and 10. So this coordinate here is 10, 0 and 10. Now I have 2 points, I can work out my straight line equation. So y is equal to mx plus c, I can work out my gradient. M is equal to y2 minus y1 over x2 minus x1, where my points are 0 and 10 and 6 and 4, 2 points on the straight line graph. Sub into the formula and you'll get an answer of m is equal to negative 1 for your gradient. So y is equal to negative 1x plus c. Substitute any point that's on the green graph, so 6 and 4. So 6 is your x value and 4 is your y value. So 4 is equal to negative 1 into 6 plus c. C is equal to 10. So my final answer there, y is equal to negative x plus 10. The next one, calculate the average gradient of f of x between x is equal to 1 and x is equal to 3. Now, for average gradient, what I do is I work out the full coordinates of each of the x values that are given to me. So if x is equal to 1, I'll substitute that into my f of x equation. So if x is equal to 1, I subbed it in here to my, f of x equation here, and I got an answer of 4. So my first coordinate is 1 and 4. If x is equal to 3, I subbed it in again to my f of x equation and I got an answer of negative 2. So my second coordinate is 3 and negative 2. All I do now is I substitute into the normal gradient formula. So I can write now average gradient is equal to y2 minus y1 over x2 minus x1. Sub in these 2 points here into the gradient formula and work out your gradient. Negative 3 is my answer for average gradient here. The next one, find the turning point of f of x. Now to determine the turning point, we use the equation x is equal to negative b over 2a. We worked out the equation of f of x earlier, and that was x squared minus 7x plus 10. So my b value was negative 7 and my a value was 1 from that equation. So my x works out to be negative 3, 5 here. I take that negative 3, 5, x value of my turning point, I sub into the original y equation, and I get 46,75. So my new turning point of f of x is negative 3, 5 and 46,75. The next question, if h of x is equal to negative f of x, describe the transformation. I know that h of x can be written as y, so can f of x. So negative f of x becomes negative y. And I know that if y changes to negative y, that is a reflection across the x-axis. The next question, determine the equation of h of x. So h of x is equal to negative f of x. So I'm going to put a negative in front of my f of x equation here. Open out the bracket, and h of x is equal to negative x squared plus 7x minus 10.